How do you design a professional database? What steps should you follow in order to come up with such a design? What is an ER diagram and how does it help with that process? To know all the answers to these questions, let's watch in this video. Hello and welcome. My name is Elhelw. I want to take a little break from all the database internals videos that I was posting and just wanted to post something a little bit different today. Today I wanted to start talking about some things related to using a database. So building an application on top of a database and so on. What are some of the issues or what are some of the things that we have to deal with as someone who is using a database system. Some examples of the topics that we're going to talk about include database design, which we are talking about today. Also things like query performance tuning, for example. There are definitely other topics for sure. If you have any specific topics that you want me to talk about related to using a database engine, please let me know in the comments and I will try my best to get to that. So yeah, as I mentioned, in this particular video, I'm going to be talking about database design. This has been a widely requested topic. So looking at it from a very high level, we're going to talk about these steps kind of like, in summary today. And then I'm happy to do follow-up videos to talk about some of these things in detail. Okay, so what is database design? Basically, if you are building an application that requires a database, right? Or if, let's say, a customer is building an application and they want you to build a database for them to use with their application. How do you design this database? What are the steps that you need to follow in order to come up with a good database design that that works well with the use case that you have or that your customer has? So let's talk about these steps today. Before I get into the steps themselves, I wanted to kind of like give a quick disclaimer at first that you might find in some other sources or videos or some other documentation, there might be a different number of steps. The steps might be named something different. They might be structured a little bit differently, but in the end, once you get into the details of them, you'll see that the idea is pretty much the same all over. So let's see what the database design steps look like at a very, very high level. Usually it starts with gathering the requirements, and then you use those requirements to figure out what kind of database management system you're going to use. You also use these requirements to start doing some analysis and building a database model for the kind of data and queries that you want to use in this database. You take that model and then use it as the input to the logical design. You produce a more refined model or actual actual design, including some of the tables that you have. And then you have to do the physical design on top of that. And then finally you create the database. So let's have a little bit more information about each of these steps and see how they interact together. Starting with gathering the requirements. Gathering the requirements, I would argue, is probably the most important step in database design. It's also the hardest. Usually you're working with a customer has the business requirements in their head, and you want to get from them the information that will help you design the database. That is not always straightforward. Customers usually don't know what database look like or what kind of information you need from them. So it might need a lot of back and forth until you figure out what they want, or you help them figure out what they want. You want to understand what kind of information they want to store in the database, right? Like what kind of application they have. Maybe they have an e-commerce application and they care about things like orders and transactions and shipping and delivery and customers and products and so on. Maybe they have something, I don't know, they're developing an application for a university, for example, and they care about students and courses and instructors and whatnot. So yeah, you want to understand what kind of information you're going to store there. Most importantly, you will also want to understand what kind of operations they want on top of that data, right? Like what kind of reports they want to generate, what kind of questions they're going to be asking the system and want answers. A lot of the time, especially if this customer is just transitioning or the first time for them to build an application or something, they may not have a very clear picture on what they want. So like I said, it may require a lot of back and forth, kind of getting some initial ideas from them maybe, and then you should actually start giving them suggestions on okay, maybe I wonder if this is what you're looking for, or I wonder like, if this kind of queries might be useful in your case. Once they kind of like get an idea of what things you could help them with, or what kind of queries you could answer for them, they will start to get other ideas, and kind of like the ball will start rolling from there. So yeah, this might be a little bit time consuming and tedious process, but the more time and effort you invest in this, the better idea you'll get about what the database will look like, what kind of queries you want to support, and so on. Of course, this is much easier if you are the one also developing the application. Like, if you're having a new startup, for example, and you know the application that you're building, and you know exactly what kind of queries you have, what kind of data that you'll need. In this case, it's much easier. But yeah, if you're working with someone else, then it gets a little bit difficult. More specifically, I guess, what like the questions that you want to be asking, or like the kind of things that you want to understand, right? Like you want to understand, like I said, what kind of data you're going to be storing, what kind of queries you're going to be asking, what kind of reports you want to generate, but also like who is going to be using the system, what kind of users does the system have, right? And what kind of maybe permissions that each user have. Do different users, for example, get a different view of the system? Do they have different capabilities? So all that information is something that you need to also understand while gathering those requirements. Now, once you have that information, the next step is going to be deciding on which database management system to use. I've already posted a video about relational versus NoSQL databases, and I kind of like, touched upon this topic a little bit in that video. I'll leave the link in the description as well as up on the screen. But basically, deciding on what kind of database management system to use depends on many things. So the first thing is the kind of data that you're dealing with. What kind of data is it? Is it highly structured data that looks very relational, looks like tables? Is it more like graph data? Like, are you building the next, the next Instagram or the next social network, and you want to, store things about users and posts and comments and all that, and have it in a graph format? Is the data represented more as semi-structured, like XML or JSON documents, for example? So all these questions will kind of like give you an idea of which direction to start kind of like, leaning towards. The kind of data alone is not enough, because the same kind of data can often be represented in different ways. So it might give you an idea, but it's not the only thing that you need to consider. Another thing you want to look at as well is how will the data be used? Like I said, you want to understand what kind of queries you're looking at, what kind of reports you want to generate. Is the application that you're looking at looking for something about graph traversal, for example? Like, does it want to start from one type of object and then get all the neighboring objects, and then go from that to the neighboring objects and so on? So basically doing graph traversal on the data. Does the application mainly focus on analytical type of queries? Like, is it doing lots of aggregation, lots of joins, this kind of thing? Is it doing something like a time series analysis, perhaps? So try to understand what kind of queries you're going to run, and that will also give you another data point to understand what kind of database management system you want to use. Another thing you want to also consider is what additional features the application might require, right? So are you looking, for example, for something that requires transaction processing? Does the application require the schema to be flexible? Does it anticipate a lot of data and it wants to be highly scalable, for example? So all these things will also kind of like, steer you towards what kind of database management system you might need. So that is an important step in design. And most of this information will be part of the requirements gathering that you did in the first step. One thing to note, just want to put this out there, is that in many cases, the right answer is usually a relational database. I know like these days, a lot of people are going more towards NoSQL databases, and it seems to be helpful in many cases, especially like, if you're doing a web application and stuff like that, or mobile application. But I find that in many cases, a relational database will actually do the job and will do it better. Many people go to NoSQL databases just because it's more flexible. They don't have to like, invest as much time in actually designing the database. That is not the right approach. Like, if you think it's just kind of like a way to save time on designing the database, so let's just go with something that has a flexible schema, that is not the right approach. So try to invest as much time in actually designing your database first, and then see if what you need is a relational database or a NoSQL database. For the rest of this video, just for the sake of explaining the steps, I will assume that we're dealing with a relational database. So we'll describe the steps in that context. Okay, so once we've chosen the database management system, the next step is the analysis step. This is also another one of the most important steps in this workflow. And basically what we want to do here is we're trying to model our data. We're trying to have some representation or conceptual model of what the data will look like in our database. Again, we've already collected the kind of information that we need, but how do we organize this information? How is this information connected to each other? How does it serve the queries that we want to run on the database, right? So we're trying to build a data model that captures all that. Why is it important to get this right? First of all, you'll never get this right 100% from the beginning. So you need to know that. There will be multiple iterations. You'll need to refine this over and over until you get to the right point. But you're trying to get it as much as possible early on. Because if you don't do that, then you may miss on storing the data in the right way. You might miss on you might miss some of the data that you need. Maybe the relationships between the data is not going to be correct, so some of your queries that you want to do will not work. Or you might have to overcomplicate the queries in order to deliver the information that you need because you did not capture the data relationships correctly in the beginning. Of course, all of that means extra effort and extra money. You need extra effort to try to update your database or do something in a different way than has been done initially. And you also need money. If the queries are not efficient, you're paying for extra CPU, you're paying for extra storage sometimes, you're paying for more I/O. If you are storing your data on the cloud, then you're paying for all that CPU and kind of whatever the service that you're using. So again, building a correct data model from the beginning saves a lot on the long term. So invest time in that. Now, in the analysis phase, we want to, as I said earlier, we want to come up with this model, right? It's a conceptual data model that describes how the data is organized and how it connects to each other. Mainly, we're looking for three things. What entities do we have? What attributes do these entities have? And then what are the relationships between them? In order to do that, or as a way of doing that, there are different tools that help. One way to do this is using a graphical method called an entity relationship diagram, or ER diagram, or ERD. It has many different ways of naming it. You can represent it in this way to make it easier for yourself as the analyst or the person doing the analysis, as well as the customer who owns the application, to be able to communicate and iterate on that design or on that model until you get it right. It does not require someone who is a database expert to understand it. It's usually done in a very simple representation, so anyone should be able to understand what that kind of graph represents. There are many ways to represent the elements of the ERD. I will show one of them here, but again, if you see other ways to represent that in other documentation or in other sources, that's fine. It's all the same thing. So an ERD or ER diagram might look something like this. So you will see different entities. Forget the colors for now. The colors I just added for emphasis, but you have some entities, the ones that are represented here with the green rectangles. You have some attributes, the ones that are in the orange ovals, and some relationships, those lines with the blue diamonds on them. I'll get into each of these and what they mean, but this is kind of like a rough shape of what a very small ER diagram might look like. In a large database, you will have way more types of entities and attributes and relationships, so it will look much more complex, but I just wanted to show something simple here. So starting with entities. What are entities? Entities are any type of thing that you want to represent in your data. This thing might be a physical thing, like a person or a car or a building or an actual product, for example. So these are all physical entities. But there could also be some conceptual entities. If you're talking about a company or a bank account or an educational class, for example. So these are not physical entities. These are conceptual entities, but they're still entities nonetheless. So an entity could be any of these things. So it's something that has data associated with it that you want to represent in your database. So first step of the analysis is trying to identify all these different types of entities that you want to deal with. Of course, the types of entities that you're dealing with depend on the kind of application that you're building or that someone is building and in which they want to use the database for. So if someone is building like a sales application, for example, then usually the types of entities that you want to deal with would be customers, accounts, products, orders, stuff like that. If you are building an application for, let's say, a university or like some educational institution, then usually the types of entities that you're looking at would be student, course, instructor, and so on. If you're looking at an application for like a sports tournament, for example, then some of the entities would be player, team, game, season, like all this kind of stuff. So depending on the types depending on the type of the application, this will give you a rough idea of the types of entities that you're dealing with. Once you have identified the entities, now we need to figure out what are the attributes that we're going to store with these entities. So the attributes basically are the properties or the details associated with each entity. They give you all the information about that entity. So if you're looking at a customer, for example, some of the attributes could be name, email, address, and so on. Of course, each type of entity may have an infinite number of potential attributes. You want to obviously focus on the attributes that are specific or that are relevant for the application in question. Like if I'm storing an entity about a user, right? A user could have contact information like email, address, stuff like that. But a user could also have height, weight, eye color, hair color. Do you need all of that or not? If you're building an e-commerce application, you need the email, you need the address because of shipping, for example, or delivery, stuff like that. But you don't need to know the customer's height and weight. On the other hand, if you are building a fitness application, then you need the height and weight, but you don't need their address. So depending on what you're trying to do, try only to keep the kind of attributes that you actually need and that are relevant for the application. So just to show this again, what this would look like in an ER diagram. So usually an entity is shown as a rectangle, and then the attributes are these ovals, and they're connected to the entity that they represent. So here we have a customer entity that has name, address, and email attributes, for example. Okay, now that we have the entities and attributes, the next thing that we want to identify is the relationships. And ER diagram stands for entity relationship diagram. So entities is one thing, relationship is the other major component. Relationships tell us how these entities are connected to each other. Generally speaking, there are several types of relationships. We want to understand the cardinality or the number of entities that can connect to each other. So you might hear about things like one-to-one relationship or one-to-many relationship or many-to-many relationship. What does that mean? A one-to-one relationship means that the two entities that are connected, each instance of entity A connects to only one instance of entity B. And also, each instance of entity B connects to one instance of entity A. 1 or 0 usually, but not more than 1. There are ways in the ER diagram to say that something is optional, like can it be 0 or not, or can it also be 1, but I'm not going to get into this level of detail today. But just know that one-to-one means that only one object from this side connects to one object from this side, and that's it. What's an example of this? If you're looking at a company database, for example, and you have employees and you have like desk locations, for example, each employee is assigned a desk, and each desk only is assigned to a single employee. So this is a one-to-one relationship. The second type is one-to-many, or depending on how you look at it, it could be one-to-many or many-to-one. Sometimes these are represented in different ways in the database. Sometimes they're represented in the same way depending on the semantics of the entities. But basically the idea is that one object from this side connects to multiple objects or multiple instances on the other side, whereas each object on the other side connects to only one object on the first side. What's an example of this? If we are looking at a banking application, for example, and for simplicity, assume that an account cannot have multiple holders. So Each account has only one customer associated with it, but each customer may have multiple accounts. So the relationship is one on the customer side, many on the account side, because each one customer may have many accounts, but each account may have only one customer associated with it. You could also think about school projects. Each project has multiple students working on it, but each student is only working at one project at a given time. So again, this is a one-to-many relationship. The third kind is many-to-many, where each instance is connected to multiple instances on the other side in both directions. What's an example of that? If you look at students and courses, right? Each student is taking multiple courses at the same time. And each course is taken by multiple students at the same time. So this is a many-to-many relationship. How do we represent this in the ER diagram? We represent this using the diamond shape that we've seen. So this is what it looks like. So if we have, let's say, employee and desk, this is the one that we described. So we have a one-to-one relationship between them. So we have the diamond that says assigned. Assigned here is the name of the relationship, and we have one on both sides. But between employee and team, each team contains multiple employees, and each employee is only working on one team. So this is a one-to-many relationship. So the one is on the team side, the M is on the employee side. So this is how relationships are represented in an ER diagram. One thing to note is that some relationships may actually also have attributes. In this particular example, they don't. The attributes are only with the entities, but in some cases, a relationship may have attributes. This can happen to any relationship, but it's very common in the many-to-many case. So an example to that, the one that we mentioned, if we have student and course, right? The relationship here is the enrollment, and it has like, M and N to illustrate that this is a many-to-many relationship. But it also has attributes like the midterm and the final scores, because these attributes are not dependent only on the student, but they depend on both the student and the course. So like for student X, course A, the final score is blah. So this information is not specific to the course, it's not specific to the student, but it's specific to the enrollment information. So this is one example where a relationship may actually have attributes. All right, now we're done with the analysis, and we have this ER diagram that captures all our entities and relationships and attributes and so on. What's next? Next, we go to the logical design phase, where we try to convert this into tables. Since we're working with a relational database, now we have tables. Usually the tables correspond to the entities that we have. Sometimes they correspond to some of the relationships that we have as well. We already know what the attributes are, so these will become attributes in the tables. We can also kind of like get an idea of what each attribute type might be, roughly. Like we know which ones are numeric, which ones are string, which ones are date, and so on. So we can also kind of like record this information. We also want to determine what is the primary key for each table. So looking at the attributes that we have, which ones of these attributes could be a good primary key? If none of them is, then maybe we need to add another attribute, like an ID attribute, for example, for some of the entities if they don't have one, and that could be the primary key. Also, the relationships will tell us about foreign keys. What foreign keys do we need to define in those tables? Which tables contain information that point at other tables? So we'll get that from the relationships that we have defined. Another thing that we also want to do is normalization. Normalization is a step. I like to consider that part of logical design. In some literature, you might see that spelled out as a separate step. Basically, these are some checks that we do on the model that we have, on the tables that we have illustrated, and we think these are the tables that we want. So normalization is a bunch of steps and checks that we iterate over these tables to make sure that the design has some guarantees and has some fail safety against inconsistencies that may occur. I will have a separate video on normalization because that's a very important topic and it deserves its own video. But for now, let's just assume that this is one step of logical design that will help us refine our kind of like initial tables even more. So at this point, we have a better idea of what the tables look like. What are the primary keys? What are the foreign keys? We might represent them in a way like this. Again, this is another way of how to represent an ER diagram. Like I said, there are many ways to represent it. So you might see this representation in some places. It lists each entity as a table. It lists the attributes, the primary key, the foreign key, and kind of like, the types of each attribute. You'll find several tools online that allow you to draw or enter the ER diagram. Some tools may even give you the ability to generate SQL statements to create your tables based on that. I will probably list some of these tools in the description, but yeah, if you do a Google search for ER diagram, you'll come up with lots of different tools there. So yeah, there's no shortage of those. So after that, the next step is the physical design. This is the step where we actually want to do multiple things. First, determine the actual data types. So in the logical design, we said, okay, some of these attributes are numeric, some are strings, some are date. Now we want to map that to the actual types for the specific DBMS that we're using. So like if we're using Oracle, if we're using SQL Server, the names of the types might be slightly different. So we want to get the actual types from that database system and start using those in our table definitions. We also want to look at things that will help the performance of the queries. So which indexes do we want to create? Do we want to do partitioning or not? How do we partition our tables? Do we want to do sharding or not? Things like that are also part of the physical design. So this is the part where we kind of like, try to figure this out. Once we have that, basically now we have, okay, SQL statements ready to execute. We're ready to actually go and start, creating our database. So this takes us to the last step in the database design, which is the database creation. So now we're just going to take all the SQL statements that we've built for creating the different tables that we have, creating indexes, partitioning, all that, and we're going to go and execute these statements, and then also start loading the data into the tables that we have, start updating the indexes, start collecting statistics, do all that. So this is part of the creation, and now the database is ready to use. Of course, this is not the end of it. Like this is the end of the initial design, but like as long as the database is in use, there is continuous maintenance that happens on it. You might need to add some tables, change some tables, create new indexes, drop some indexes. So there is usually continuous maintenance happening on the database for as long as it is online. Now to summarize what we've talked about. So again, we have been talking about database design. What does it take to design a database to serve a particular application, whether that application is yours or someone else's application? The first step, as we said, is to gather the requirements, understand what kind of information we're storing, what kind of operations we need to do on the data, what kind of reports we want to generate, what specific requirements do we need in terms of, do we need transactions, do we need flexible schema, what kind of database we're looking at. So that helps us to choose what database management system to use. And then we take the requirements and start modeling our data. How do we organize the data that we have? What entities are we dealing with? What attributes do they have? What relationships connect these entities together? Which ones are one-to-one, one-to-many, and so on. It's important to understand that. Use the ER diagram tool to try to model this data. Iterate over that until we have a good good way of organizing the data that we have. From that, we go to the logical design, have kind of like an initial idea of what the tables might look like, what are the primary keys, what are the foreign keys, do the normalization if we need to, and then go to the physical design where we map the tables that we have to the actual data types of the DBMS that we're using. Also figure out what indexes that we need, partitioning, sharding, all these other aspects of the database that we need. Basically now we have all these kind of like SQL statements ready to execute. We can run them, create the database, load the data, and then it's ready to use. As I said, this kind of like goes over the steps in very high level. I will have another video to describe normalization and what it means specifically. But if you would like me to talk about any of the other steps in more detail, please let me know and I will try to do that. Yeah, I think that's it for today. Again, if you like the video, please hit the like button, subscribe to the channel in order to get the updates as I release them. And with that, thank you so much for watching, and I will see you in the next video.